Good day, friends, and welcome to today's WASE online channel. I'm Philip, your instructor. But before we start our lesson for today, I need you to subscribe for our channel if you've not already done that. We need your subscription for the survival of this program. To do this, just go below this video and tap the subscribe button. Thank you so much for subscribing for us. Now let's move straight by looking at the topics for today. Today we'll be looking at part 6 of set and set operations. And under this part we'll focus mainly on how to solve practical problems using Venn diagram. And in this case, we'll be solving two set problems. Now we'll be starting with two set problems. But before we do this, I'll need us to remind ourselves of some important regions on a Venn diagram of two intersecting sets. So let's quickly look at this before we look at our two set practical problems. This is our Venn diagram of two intersecting sets, set A and set B. So first, let's look at the region A intersection B. This is our region A intersection B, the point where set A and set B meet. Now let's look at the region A. This is our region A. This region is the whole circle A. Now let's look for the region A only. This is the region A only. Remember, it is not the same as A. It is A without B. So that's why it is A intersection B complement. Now let's look at the region B. This is the region B. Now let's look at the area or region B only. So this is the region B only. Remember, B only is not the same as B. Whilst B is the entire circle B, B only is just the crescent part of the circle B. And it's the same as A complement intersection B because it is B without A, so B only. Now let's look for the region that is neither A nor B. So this is the region that is neither A nor B. So in this Venn diagram, those people who do not take part in activity A and do not take part in activity B would be in the shaded region blue. So they are neither A nor B, and they are represented by A union B all into bracket complement. Now I need you to remember these shaded regions. They are so important, we will need them for our Venn diagram problems. So please remember them. So let's start by looking at how we can use the Venn diagram to solve two set problems. Let's look at our first problem. And I'll read the problem. In a class of 40 students, 30 read maths and 20 read English. Each student reads at least one subject. I draw a Venn diagram to illustrate this information. How many students read both maths and English. So that's the problem. Before we come out with solution to this problem, let's try and take up or pick up some important information from it. From the question, we are told that there are some people in the class. Some of them read mathematics and some of them read English. So what we're going to do is this: we are going to represent mathematics by capital M and English by capital E. Again, we are told that the total number of students in that class is 40. Remember, total number will be represented by the universal set. So let's write that information down. So n into bracket universal equals to 40 would represent the total number of students in the class. We are also told that in this class, 30 of the students read mathematics. So let's write this information down. N into bracket M equals to 30 means number of students reading mathematics. Remember, we used M to represent mathematics. So that is it. Let's look for the next important information from the question. We are also told that 20 of these students read English. So let's write that also down. N into bracket E equals to 20 means number of students reading English. So let's look for the next information. The next important information we are given is this: that each student reads at least one subject. What this means is that every student in the class at least reads either maths or English. We do not have anybody in this class who does not read anything. Also from the question, we are asked how many of the students read both maths and English. Now, we are not told the number of this group of students. Rather, we are asked to find the number of this group of students. And of course, because we do not know, what we're going to do is this: we are going to represent that information by X. So X will indicate the number of students who read both maths and English. So let's write that information down. So here we have the number of those reading maths and English at the same time equals to X, because we do not know the number. And I believe you know why we have maths intersection English representing both maths and English. I remember when we were looking at set operations, one of the things we said was that items that are in the point of intersection are items that can be found in two sets at the same time. Now, because we are told that we are to look for the number of students that read maths and English at the same time, represented by X, we can say that X is the number of students which will be at the point of intersection. So we'll be looking at that, and we're going to represent this, all of this information we've gathered from the question, in a diagram, the Venn diagram, and that is going to help us solve the problem. So now let's take these pieces of information we've gathered from the question onto a clean page, and we'll use them to solve for our problem. Let's do that quickly in our next slide. So let's look at the solution to the problem given to us. And these were the important pieces of information given to us from the problem. First, we know that the total number of students in that class is 40. We know that the number of students reading mathematics is 30. We also know that the number of students reading English is 20. We do not know the number of students reading mathematics and English at the same time. but we are asked to find that number. So we represented it with the letter X. The first question, I, asked us to represent this information on a Venn diagram. So let's do that. So this is how our Venn diagram is going to look like. It is, however, not complete, so we would have to use the information gathered from the question to complete it. So that's what we are going to do next. First, we'll write the total number of students in the class by the Venn diagram. So let's do this. Next, we are told that the number of students reading mathematics is 30. So let's complete that section of the Venn diagram. We also know the number of students reading English to be 20. So let's complete that as well. Now, our M intersection E, that's math intersection English, is X. So let's complete this. I believe you are not confused about this. When we are looking at shading the various regions of a Venn diagram for 2 set problems and for 3 set problems, we looked at something like this. So that is the section that represents M intersection E. Now, the entire size of the circle M is equals to 30. So what do you think will be the size of this section of the circle? Well, to get the size of that section of the circle M, all you need to do is to subtract the blue portion, the X, from the 30 to be able to get the value of that size of the circle. It's just like you having a pizza, you're taking the blue part of your pizza away and you are left with the orange part. So the same way, if you want the size of the orange part, just take X from the 30 and you get the value of that size. So that means that the orange region should be 30 minus X. Now, what do you also think of the size of the green portion of the circle E? To get its size, we just need to subtract the blue portion from the whole circle, which is 20. So what we'll do is this, we'll subtract X from 20. So that's great. We'll be able to complete the first part of our problem. We were asked to draw a Venn diagram to illustrate the problem, and this is how you're going to do it. Okay, so let's look at the second part of the problem. And in the second part, we are asked to find the number of students who read both math and English. And we represented this information by X. What this means is that if we are able to find the value of X, then X would represent the number of students who read mathematics and English at the same time. So our aim right now is to look for the value of X. So we now have our Venn diagram and we are going to use it to do this. So first, let's picture our universal set, the rectangle, as a classroom. So what it means is that we have the rectangle, which is our classroom, and everything inside are the members or the various groups or categories of students in that class. So in this particular classroom, the rectangle, we have those students who read only mathematics. That is represented by the orange color. And we also have those who read both mathematics and English. And this group of people are represented by the blue color. And we also have those who are reading only English, and they are represented by the green color. Remember, in this classroom, we do not have a student who doesn't read any of the subjects. In our earlier statements, one of the important information we took from the question was that at least all of them reads a subject. So we do not have any student who do not read any of these subjects. In other questions that we are going to solve in the future, we'll come across questions where people wouldn't take part in something, but in this particular one, we have nothing like that. So we have these three groups of people, those in the orange group, those in the blue group, and those in the green group. Now, assuming I walk into a class, and in this class, some of them are in group orange, others are in group blue, and others are in group green, and I'm asked to find the total number of students in the class, what will I do? I will simply have to add the various groups together. So I'll add the orange group to the the blue group and to the green group. I'll add all of them together to get the total number of people in the class, right? So that's exactly what we are going to apply here. Now, but we also need to remember that the total number of people in the class can also be represented by the universal set, which is 40. So now we are going to combine two things together. First, we would add the various groups together and we would equate it to the total number of people in the class, which is 40. So that's what we're going to do. So first we have the orange group. The number of students in this orange group is 30 minus x. So we write that. Then plus x. Remember, x is the number of students in the blue group, those reading both maths and English at the same time. Then plus 20 minus x. 20 minus x would represent those in the green group, that is those reading only English. So adding the various groups together, orange, blue and green together, would have to give us the total number of students in that class. So what it means that we can equate this value to the total number of students in the class, which is 40. So we've now been able to generate a simple linear equation, and we can solve for x from this simple linear equation. Like we said, once we solve for x, we've arrived at our answer. Alright, so let's solve for the value of x from this linear equation. From this equation, you can see that the negative x plus x can cancel out to give us 0. So we would have to take them out. It's now easier to deal with the rest. We now have 30 plus 20 minus x. The 30 plus the 20 will give us 50. So we would have 50 minus x equals to 40. At this point, we would have to group like terms. So we would move the x to the right side of the equation, and we will move the 40 to the left side of the equation. And that will give us 50 minus 40 equals to x. Remember, when the negative x moved to the right side of the equation, it became positive. And when the positive moved towards the left side of the equation, it became negative. So remember this. So we now have 50 minus 40 equals to x. That will give us what? 50 minus 40 will give us 10 equals to x. So we now know the value of x to be 10. And we also know that number of mass intersection English is x. What it means is that we've been able to find the number of students who read mathematics and English at the same time. So that value will also be 10. Therefore, number of students who read both mathematics and English at the same time is equals to 10 students. It's as simple as that. Let's look at another problem. Let's look at the example 2. And I'll read the problem. In a class of 50 students, 30 read economics and 17 read government. 7 read neither of the subjects. I draw a Venn diagram to illustrate this information. How many students read both subjects? So let's get the most important information from the question. We write them down and use them to solve the problem. First, we are told that in this class, we have those who read economics and we also have those who read government. So what we're going to do is this. We are going to represent economics with capital E and government with capital G. Also in this class, we are told that the total number of students is 50. Therefore, this total number of students in the class will be represented by n into bracket universal equals to 50. Again, the number of students in the class who read economics is 30. So let's write this information down. Number of economic students is equals to 30. 17 of these students read government. So number of government students equals to 17. From the question, 7 read neither of the subjects. What this means is that there were 7 students in the class who did not read either economics or government. In fact, they didn't read any of these 2 subjects. So we would have to write that one down. It's an important information. So number of students who did not read any of these 2 subjects will be represented this way. And here we represented this information by E union G, that's economics union government, all into bracket complement. Finally, we are told that there are some students who read both subjects, that is economics and government. But we are not given their number. However, we are asked to find how many are these students. Of course, because we don't know their number, we would represent this information by x and would look for the value of x. So this is how we are going to write this information, which means that number of students who read or read economics and government at the same time, that is economics intersection government, equals to x. Now, we've gathered the most important information from the question. So we are going to carry them to a fresh page and would use them to solve our problem. So let's look at the solution to this problem. First, we write the important information we've gathered from the question down. First, we know that the total number of students in the class is 50. Number of economic students is 30. Number of government students is 17. Number of students who did not read any of the two subjects is 7. We are made to understand that some of the students read both subjects. That number wasn't given to us, but we are rather asked to find that number. So we represented that by X. So economics intersection government is X. Let's write that again. The first question asked us to illustrate the following information on a Venn diagram. So we are going to use this information we've gotten from the question to draw a Venn diagram. So we have our Venn diagram, but it is not complete. So let's use the information gathered to complete it. So we first write the total number of students in the class by the Venn diagram. 30 students read economics, so we will write that down. 17 students read government, so we would write it down in the Venn diagram. X students read both economics and government, so we would write that also down at the point of intersection. Remember, if you have both, then it should be intersection. That's the intersection region. Now, the whole circle E, or economics, represents 30 students. So if you are asked to tell the number of students that will be at the orange region, what would be your answer? If the whole circle is 30 people or students and the blue part of it is X, then the orange part of it should be 30 minus X. Remember, you have a circular pizza, and you're taking the blue portion of the pizza. So you'd have to subtract it from the whole pizza to get the orange portion of the pizza. So that's what it is. So you get 30 minus X, representing the orange section of the circle. Now the whole circle G is 17 students. So if you are asked to calculate the number of students that would fill the green section of circle G, what would be your answer? To do this, you would have to subtract the whole of the blue section from the circle G, which is 17. The blue section is X. So the green section will be 17 minus X. We are left with the final item we would have to put on the Venn diagram. Remember, in the question we were told that there were some students who did not read any of the two subjects. So we would have to place that information in the Venn diagram as well. Which section of the Venn diagram should we put this information? So this hash region represents the number of students who neither read economics or government. At the beginning of the video, we showed this region, and in fact it's even very clear from the diagram on the screen. The hash region is the region that is outside of economics and government. So clearly that hash region tells us that is the region where the students there did not read economics or government. So that is it. So this brings us to the end of the first part of the question. Now let's look at the second part of the question. And in this second part, we are asked to find the number of students who read both economics and government at the same time. So again, we would imagine the rectangular box as the classroom, and everything inside the box would represent the various groups of students in the classroom. So we have students who are in group yellow or orange, sorry. We have students who are in group blue. Then we also have students who are in group green. Then finally we have students who are in group hash. So if we are asked to tell the total number of students in this class, we would have to add all the various groups together. So let's do this quickly. And remember, the total number of the people in the class we also know is equals to 50. So whatever we will get after we tabulate the total groups in the class, we would have to equate it to 50. So that's what we're going to look at next. So we have the first group in the class, the yellow group, which is 30 minus x. This group represents the number of students who studied or read only economics. So let's write that down. We will then add the blue group, which is x. Remember, x represents the number of students who studied both economics and government. So we would add them to the orange group, plus the green group. And the green group is 70 minus x. And this group represents those that read or read only government. We would finally add our hash group, which is 7. And this represents the student who did not read any of the two subjects. We will then equate this to the total number of students in class, which is 50. So we've been able to generate this linear equation. And from this linear equation, we are going to calculate the value of x. So let's follow the steps and get this done. From this equation, the negative x and x will cancel out, and they will give us 0. So we'll just ignore them. That makes the work easier for us now. We now have 30 plus 17 minus x plus 7 equals to 50. 30 plus 17 plus 7 will give us 54. So we will now have 54 minus x equals to 50. At this point, we would group like terms. So the x would move to the right side of the equation, and the 50 would move to the left side of the equation. Remember, the x is negative, so when it moves to the right side of the equation, it will be positive. The 50 is positive, so when it moves to the left side of the equation, it will be negative. So when we do this, we will get 54 minus 50 equals to x. 54 minus 50 is 4. Therefore, our x would also be equals to 4. So finally, we've been able to determine the value of the x. As we already know, x is the number of students who read both economics and government at the same time. Therefore, number of students who studied both economics and government at the same time is equals to 4. That's very easy, isn't it? So let's look at our next example. Let's look at the third example. In a class of 55 people, 33 eat fufu, 20 eat banku, 15 eat both fufu and banku. 1. Draw a Venn diagram to illustrate this information. 2. How many people do not eat any of the foods? So as usual, let's put the most important information from the question down. First, in this question, we are told that there are people in the class who eat banku and there are those in the class who eat fufu. So what we're going to do is this: we'll represent fufu by the small letter F and we'll represent banku by the small letter B. Again, in this class, we are told that the total number of people is 55. So let's write that information down. The number of fufu eaters in this class is 33. So let's write it down. The number of banku eaters in this class is 20. So let's write it down. The number of people who eat fufu and banku at the same time we are told is 15, so let's write this also down. Again, in this class, we are told that there are some who do not eat any of the foods. We are, however, not given the number of people in this group. We are rather asked to find this number. And because we do not know, we will represent it by X. This will be represented by number of F union B all into bracket complement equals to X. So, we've been able to get the most important information from the question. Let's move it to a fresh page and use it to solve our problem. So let's look at the solution to our problem. These are the most important information we gathered from the question presented to us. First, our total number of students is 55. Secondly, our fufu eaters are 30 in number. Next, our banku eaters are 20 in number. The number of students who eat fufu and banku at the same time is 15. We have used X to represent those who do not eat any of the foods. So we'll first use the information to draw our Venn diagram. This is our Venn diagram of two intersecting sets. So first, we'll write the total number of people in that class by the Venn diagram. The number of fufu eaters are 33, so we'll write that information in the Venn diagram. So that whole circle represents the number of people who eat fufu. We would use the second circle to represent the number of people who eat banku. That number is 20, so let's write it inside the Venn diagram. Now the point of intersection between the two circles, F and B, is the point where you have the people who ate both fufu and banku at the same time. So we would represent that point of intersection by 15. Now we know the number of students in the blue region to be 15. But assuming I give you another region, this yellow region, and I ask you how many students will be in this region, what would be your answer? First, we know the whole circle representing Fufu is 33 people or 33 students. So if we cut the blue region from the 33 people, which is 15, what will we get? We'll get 33 minus 15 to be the yellow region. And of course, 33 minus 15 is 18. So we'll write 18 at that yellow region. Again, if I give you this green region and I ask you to find the number of students in that region, how would you go about this? Remember, that whole circle is equals to 20. So if you take the blue portion out of the 20, which is 15, you get 20 minus 15 for that green region. And of course, 20 minus 15 is 5. So we'll write 5 at that region. Finally, the item we have to put on this Venn diagram are a number of people or students who do not eat any of the foods. Where do you think we should write this information? As you can see from the Venn diagram, the gray portion is the area that shows items that are outside of fufu and banku. So we should put it at the gray area. So that's what we are going to do next. So we've been able to solve the first part of the problem, which is to draw the Venn diagram. At this point, we are going to use the Venn diagram to solve the second part of the problem. So let's remember that our rectangle represents the classroom, and every item in the rectangle represents the various groups of people in the class. So we have the first group of people represented by yellow, second group represented by blue, third group represented by green, and the fourth group represented by gray. So if we have to tell the total number of people in this class, we just need to add those various groups. So that will be 18 plus 15 plus 5 plus x. But we need to remember that this total is also equals to the universal, which is 55. So we have 18 plus 15 plus 5 plus x equals to 55. This is a very simple linear equation, and we can solve for the value of x from this linear equation. So first we add 18 to 15, and that's to 5, and that will give us 38 plus x equals to 55. To find the value of x, you need to move the 38 to the right side of the equation, and it will become negative 38. The x would stand alone. So now we have x equals to 55 minus 38. When you do this calculation, 55 minus 38, you get 17. So that means that our x is equals to 17. Since our x represents the number of students who do not eat any of the foods, what this means is that the number of students who do not eat any of the foods is equals to 17 students or people. Let's look at the next example. Let's look at question 4. A survey of 100 students shows that 30 played both soccer and volley. 10 liked neither of the sports. Twice as many students liked soccer as volley. A. Draw a Venn diagram to illustrate this information. B. How many students liked volley? And C. How many students liked soccer? Let's pick up the most important information from the question. From the question given to us, some of the students played soccer whilst others played volley. So we would represent soccer by capital S and volley by capital V. From the question, we are told that the total number of students who took part in the survey was 100. So you would have to write this information down. Again, from the question, we are told that 30 of these students played both soccer and volley. This is soccer intersection volley. So number of S intersection V equals to 30. Let's write this information down. Again, in the question, we are told that 10 of these students liked neither of the sports. What this means is that we have 10 students who do not like soccer and volley. So this information would have to be written down. It's important information. So S, that is sports, soccer, union, volley, all into brackets, complement is equal to 10. From the question, twice as many students like soccer as volley. What does this information mean? Well, this information means that for any number of students that liked volleyball, times 2 of that would like soccer. So for example, if one student liked volley, 2 times 1, which is 2, would like soccer. Another example, if 2 students liked volleyball, then 2 times that 2, which is 4, would like soccer. But we do not know the number of students that liked volleyball. So we would represent the number of students that liked volleyball by the variable x. What this means is that the variable for soccer will be 2x. So let's write them down. So as you can see, we represented the number of students that liked volley by the variable x. So what it means is that we would have to represent the number of students that liked soccer by 2x. At this point, we've been able to gather all the most important information from the question. Let's take them to a fresh page and use them for our solution for this problem. Let's look at the solution to this problem. So first, we'll be writing all the information we got from the question. The total number of students in the class is 100. Number of students who played soccer is 2x. Number of students who played volleyball is x. Number of students who played soccer and volleyball at the same time is 30. Number of students who did not play soccer and volleyball is 10. So at this point, we are going to use this information to complete our Venn diagram. First, we would draw our Venn diagram of two intersecting sets. We would then use our information to complete this Venn diagram. We will start by writing the total number of students by the Venn diagram. The total number of students who undertook the survey was 100. One of the circles would represent the number of those who play soccer. Number of those who play soccer is equals to 2x. The second circle would represent the number of those who play volleyball. This is NV equals to x. The area where the two circles interlock is what we call the area of intersection. This area would represent the number of students who play soccer and volleyball at the same time. The value of this is 30, so we would write 30 at that area. Now let's look for the number of students who would represent the yellow area. To get the number of students who would represent this area, remember the whole circle represents number of students who play soccer. So to get the portion for the yellow area, we would have to subtract the blue area from the entire circle. So what this means is that we would have to subtract 30 from 2x. Now let's look for the number of students that would occupy the green area. To get the number of students who would represent this green area, we first need to remember that the whole circle is equals to x. So if we take out the blue area, which is 30 from the x, we would get x minus 30. Finally, the gray region would represent the students who do not play either soccer or volley. So that will be represented by its value, which is equals to 10. So we are done with the first part of the question. Let's look at the second part of our question. In the second part of our question, we are asked to calculate the number of students who played volleyball. So let's look at that first. To be able to do this, we would have to calculate for the value of x. How do we do this? So first, we would add the various groups of people or students in the class, and we'll equate that to the total number of students in the class, which is equals to 100. So the first group of students in the class are those in the yellow group, and that is 2x minus 30. So we write the 2x minus 30, then plus those in the blue group, so that will be plus 30, then plus those in the green group, which is x minus 30, so that will be plus x minus 30, then plus those in the gray group, which is 10, so plus 10, and everything will be equals to the total number of students in the class, which is equals to 100. The minus 30 plus 30 would give us 0. So we would ignore the two of them. So what we would do next is to group all the like terms in the equation. So we have 2x plus x, that would give us 3x, and negative 30 plus 10 will give us negative 20. So we'll therefore have 3x minus 20 equals to 100. To find the value of x, we would have to move the negative 20 to the right side of the equation, and it will be positive 20. Then we would have 3x stand alone on the left side of the equation. So that will give us 3x equals to 100 plus 20. 100 plus 20 is 120. So we would get 3x equals to 120. To find the value of x, we will divide the 3x by 3 and we will get x, and we will divide 120 also by 3 and we would get 40. So that will give us x equals to 40. Since x represents the number of students who play volleyball, you can therefore say that the number of students who play volleyball is equals to 40 students. Let's look at the final part of the question. In this final part, we are asked to calculate the number of students who play soccer. Remember, the number of students who play soccer is equals to 2x. Now that we know the value of x, we can substitute the value of x, which is 40, into 2x, and we can get the number of students who play soccer. So number of students who play soccer will be equals to 2x, which is equals to 2 times 40, because the x is equal to 40. 2 times 40 will be 80. So our answer is 80 students. That brings us to the end of example 4. Let's look at example 5. Let's look at question 5. 46 students in a class took exams in French and Maths. 14 of them passed French only. 23 passed in both French and Maths. 5 of them failed in both subjects. First, illustrate this information on a Venn diagram. A. Find the number of students who passed in Maths only. Then B. Find the number of students who passed Maths. So as usual, we'll write the most important information from the question. First, we are told that the students took exams in French and Maths. So we would represent French by capital F and Maths by capital M. From the question, the total number of students who took the exams was 46. So that means that N total is equals to 46. So let's write that information down. We are then told that 14 of these students passed French only. The word only is very important, so let's write that information down. So 14 only can also be represented by number of French intersection m complement all into bracket, so that will be equals to 14. The number of students who passed both French and maths is 23. So F intersection M will be equals to 23. So let's write that information down. 5 of the students failed in both subjects. Would represent this by F union M all into bracket complement equals to 5. We are then asked to calculate the number of students who passed in maths only. Because we do not know this number, we would represent it by X. So French complement intersection M equals to X. Remember, French complement means without French intersection M. So what this means is that maths only without French. So let's move our information to a fresh page and we'll use it to solve this problem. So let's look at the solution to this problem. We'll first transport all of our information to this page and we are going to make use of them to solve our problem. Total number of students was 46. 14 students passed only French. So they passed only French without maths. 23 of the students passed both French and maths. 5 of the students failed both French and maths. For those that passed maths only, we were asked to find this number, and of course, because we do not know, we represented this number by the variable x. So we'll first draw our Venn diagram of two intersecting sets. We will then write the total number of students who took the exams, and this is equals to 46. We write it by the Venn diagram. The first circle of the Venn diagram, which is on the left side, would represent number of students that passed in French. Remember, we were not given this number, so we just leave it like that. And the second circle, which is the circle on the right side, would represent the number of students that passed mathematics, and this was also not given to us, so write N mathematics like that, and we'll leave it like that. Now the region where the two circles interlock is the area of intersection, and this area would represent the number of students that passed in both French and mathematics at the same time. So we'll put that information there. Remember, the number of students who passed French and maths was 23. So let's write that information at that space. Now, this yellow region would represent only F, or only those who passed French. Remember, that area does not have math inside, so it will represent only those who passed in French. We are told 14 people passed in only French. So we would write 14 in this yellow region. Again, this green region represents those who passed only in maths. We used the variable x to represent only maths. So we would write x in this region. Those who failed in both subjects will be represented by the gray region. So our F union M all into bracket complement will be in the gray region. We've now been able to draw our Venn diagram using the following information. Let's use our Venn diagram to solve the next part of our question. Our next question asked us to find the number of students who passed in only maths. To be able to do this, we can just go into the classroom and add all the various groups of people in the class and equate them to the total number of people in the class. So we would add those in the yellow group to those in the blue group to those in the green group to those in the gray group. That would equate that to the total number of people in that class, which is equals to 46. So let's quickly do this. So those in the yellow group, they are 14 in number, so we write 14 plus those in the blue group, they are 23, so plus 23, then plus those in the gray group, they are 5, so that will be plus 5, then finally plus x, which would represent those in the green group. They would equate all of the equation to 46, which is the total number of students in this class. So at this point we have a simple linear equation, and from this equation we can solve for the value of x. So first we would add 14 plus 23 plus 5. When we do that, we will get 42. So that will give us 42 plus x equals to 46. At this point, we'll move the 42 to the right side of the equation and it will become negative 42. We'll leave the x alone on the left side of the equation. So that will give us x equals to 46 minus 42. 46 minus 42 would give us 4. So that will give us x equals to 4. Since x represents the number of students who passed only mathematics, we can therefore say that the number of students who passed only mathematics is equals to 4 students. Let's look at our final question. In this question, we are asked to calculate the number of students who passed mathematics. And friends, I need you to note that mathematics is not the same as only mathematics. This is the region that represents mathematics. It is different from only mathematics. Only mathematics is just the green region, but mathematics is the green region plus the blue region, which is the 23 plus x. We've already found the value of x, which was 4. So mathematics is 23 plus 4. 23 plus 4 is 27. So therefore, the number of students who passed mathematics is 27 students. As simple as that. So let's now start with our three set problems. Well, friends, at this point we are bringing part 6 of set and set operations to an end. In our next meeting, we are going to look at part 7 of this topic. And in part 7, we'll be looking at solutions to practical problems using Venn diagram. In this case, we'll focus on 3 set problems. Thanks very much for staying with us, and please subscribe for this channel if you have already not done that. We need your subscription for the continuation of this program. Also, once you subscribe and we make or come up with new videos, we'll get you alerted. Thank you. Stay safe until we meet again in the next video.